if I put you in a maze, you have to walk down a path, hit a dead end, turn around, and try another path. That is exactly how your laptop works. It tries one answer at a time, it's reliable, but it's slow. But what if you could multiply yourself into a million copies, float down every single path at the exact same time, and only the you that finds the exit survives? That sounds like a cheat code for the universe, but it's actually how we are building the quantum computer. Inside this laptop, your phone, and the servers running the internet, everything is built on one very simple idea. The switch, we call them bits. They are either on, which we call a 1, or off, which we call a 0. Like I said before, it's simple, it's reliable, but it has a speed limit. Meanwhile, quantum computers use qubits. If a normal bit is a coin sitting flat on the table, heads or tails, 1 or 0, a qubit is a coin spinning on the table. While it's spinning, it's a blur. It is both heads and tails at the exact same time. This is called superposition. And if you have two normal bits, they can be 0, 0, 0, 1, 1, 0, or 1, 1. 4 possible combos. But your computer can only look at one combo at a time. If you have 2 qubits, there are all 4 combinations at the exact same time. Add more qubits, power doubles every time. If you have just 300 qubits, they can represent more numbers simultaneously than there are atoms in the known universe. Normal brain man eats one berry, it tastes bad, try the next berry. Quantum brain man eats all berries in the whole forest at the exact same time and only remembers good tasting berries. But a bunch of spinning coins isn't a computer yet. To make them work together, we use a glitch called entanglement. Albert Einstein called it spooky action at a distance. If you entangle 2 qubits, they become soulmates. Whatever happens to one instantly affects the other, even if you put one on Earth and one on Mars. It's like having 2 magic dice. If I roll a 6 in New York, your dice in Rome will instantly flip to a 6. By entangling our qubits, we link all of those spinning coins into one massive synchronized brain. So superposition gives us all the possible answers at once. Entanglement links them together. But if the computer is holding a billion answers, how do we pull the right one out without breaking the machine? We use interference. Think of a quantum computer like a giant wave pool. If you're looking for a needle in a haystack, say the cure for a disease, a normal computer checks every piece of hay one by one. A quantum computer lets a wave ripple through the whole haystack at once. Every possible answer creates a wave in a quantum computer. We program the computer's math so that all the wrong answers waves crash into each other and cancel out. This is called destructive interference. To show a bit clearly, wave A and wave B crashes into each other to cancel out. It's the exact same tech inside your noise-canceling headphones. Meanwhile, the right answers line up perfectly, making the wave taller and louder. Wave A and wave B line up, so the wave gets taller and louder. This is called constructive interference. Snap is a final moment when noise of all million wrong answers is destroyed, leaving only the truth. It doesn't find the answer by searching, it finds it by silencing the lies. So why isn't this in your iPhone yet? Because the qubits are incredibly fragile. If a qubit gets bumped by a stray atom, touched by a magnet, or feels even a tiny bit of heat, the coin stops spinning. It crashes back into a boring normal 1 or 0. We call this decoherence. To keep the qubit spinning, we have to build these giant gold-plated vacuum chambers called dilution refrigerators. We freeze the chips to minus 273 degrees Celsius. That is literally colder than deep space. So we know what a qubit does, but what actually is it? You can't just buy a bucket of qubits at the hardware store. Scientists actually have to build these spinning coins from scratch, and right now there are 2 main ways to do it. Method 1 is a superconducting loop. Tech companies build tiny loops out of special metals. These tiny loops is roughly 10 to 100 micrometers, a width of a single human hair. Quite massive compared to a transistor that processes bits, with a size range of 2 to 14 nanometers. When they freeze these loops to near absolute zero, the electricity inside stops acting like a normal electricity and starts to behave like the electron cloud of an atom. But how do we spin the coin? We don't use tiny robot fingers, we shoot the loop with incredibly precise microwaves. Yes, the exact invisible waves that heat up your cold pizza are used to program the most advanced computers on Earth. Second method is by trapping an ion. Instead of building an artificial atom, scientists just catch a real one. They take an electron off a single atom, which gives it a positive charge, and then trap it in mid-air using a magnetic force field. To program this one, they don't use microwaves, they shoot the floating atom with perfect invisible lasers to place it into superposition. So what is a qubit? It's either a frozen loop of metal getting zapped by microwaves, or a levitating atom getting blasted by lasers. So with this power, we can simulate new life-saving medicines in days instead of decades. The rate of developing and finding new cures and treatments will grow exponentially. We can design batteries that hold 10 times more power and imagine charging your phone once a month. We can mitigate climate change by copying the quantum tricks that bacteria use to make fertilizer, which could save 2% of the entire world's energy supply. The universe has been quantum since the beginning of time. We're just finally figuring out how to harness it. Someday soon, you won't just be watching a video about qubits. There will be the invisible engines powering the medicine you take and the tech that runs your world, silently canceling out the noise to find the truth. We're literally watching science fiction become science fact.